Hello friends, now we will start the second exercise 5.2, and in this exercise we will learn the section formula for the internal division, for external division, and the centered formula. I will explain all the theoretical part and solve examples and all examples from the exercise 5.2. Now let's start. Let's learn section formula. Let A and B be any two points in the space. This is the A and B in any two points in the space. And R be a point on the line segment AB. R is a point on the line segment AB. Dividing it internally in the ratio M as to N. M as to N. Then R bar is equals to, the position vector of R bar is equals to MB bar plus NA bar upon M plus N. Now we'll prove this. As R is the point on line segment AB, that is R lies between A and B, then AR, that is vector AR and the vector RB are in the same direction, and we have here AR upon RB is equals to M upon N. If you make the cross multiplication, then you will get N into AR is equals to M into RB. In vector notation, as M RB vector and the N AR bar have the same direction and the magnitude, and therefore M into RB bar is equals to N into AR bar. Now this RB bar can be written as, that is a OB bar minus OR bar. AR bar can be written as OR bar minus OA bar. But what is the OB bar? OB bar is the B bar. OB bar, this is the B bar. OR bar is the R bar. And next is again OR bar is R bar. OA bar is the A bar. And if we make the multiplication, MB bar minus NR bar, MB bar minus MR bar is equals to NR bar minus NA bar. And collect the terms on one side. That is a MB bar plus NA bar is equals to MR bar plus NR bar. Take R bar as a common, then in bracket you will get M plus N bracket complete R bar, and that's why R bar is equals to MB bar plus NA bar upon M plus N, and this is the section formula. Note that if A1, A2, A3, B, B1, B2, B3 and R, R1, R2, R3 divides the segment AB in the ratio M as to N, then R, I bar is equals to M B I bar plus N A I bar upon M plus N, where I is equals to 1, 2, 3. Okay. Next, the midpoint formula. R is the midpoint of the line segment AB. Then M is equals to N. That is the M as to N is equals to 1 as to 1. And then R bar is equals to 1 B bar plus 1 A bar upon 1 plus 1. And that is R bar is equals to A bar plus B bar upon 2, and this is the midpoint formula. Now the next, the section formula for the external division means what? This point R divides AB externally. Okay. Let A and B be any two points in the space, and R be the third point on line AB, dividing segment AB externally in the ratio M as to N, and then R bar is equals to MB bar minus NA bar upon M minus N. As point R divide line segment AB externally, we have either B lies between A and R or A lies between R and B. Assume that B lies between A and R. Okay, B lies between A and R. And AR, vector AR as to vector BR is M as to N. That is the A to R and the B to R. Their ratio is M as to N. Assume that the point B lies between A and R, and that's why the AR bar as to BR bar, AR bar as to BR bar is equals to M as to N. If you take their ratio, that is AR upon RB is equals to M upon N. If you have the cross multiplication, then you will get NAR is equals to MBR. As NAR bar and MBR bar have same magnitude and the direction, then we can write in this manner. That is, N times AR bar is equals to M times BR bar. But what is the AR bar? AR bar is R bar minus A bar is equals to M in bracket R bar minus B bar. If we perform the multiplication, simplify it. M R bar minus N A bar is equals to M R bar minus M B bar. Collect the terms of R bar on one side, that is the M R bar minus N R bar, and to the left hand side M B bar minus N A bar. Take R bar as a common, and then R bar is equals to M B bar minus N A bar upon M minus N. Now the note. Whenever the ratio in which the point R divides the join of the point A and B is required, it is convenient to take the ratio K as to 1. That is, whenever we want to find out the ratio in which the point R divides, then we take K as to 1. Then R bar is equals to KB bar. Instead of M, replaced by K, and instead of N, replaced by 1. That is the KB bar plus 1A bar upon K plus 1. If the division is internal, and if it isn't external, then R bar is equals to KB bar minus A bar upon K minus 1. If the division is external, means what? Whenever we want to find out their ratio, then we treat it as a K as to 1. Next, in triangle ABC, centroid G divides the median internally in the ratio 2 as to 1. This is triangle ABC, and the AD is the median, and next these are the median. All these medians intersect at the point G, and that point G is a centroid, and it divides all the median in the ratio 2 as to 1. Then here G bar is given by A bar plus B bar plus C bar upon 3, the position vector of the G bar. Next is in tetrahedron ABCD, centroid G divides the line joining the vertex of the tetrahedron to the centroid of opposite triangle in the ratio 3 as to 1, and it is given by, that is the G bar is equals to A bar plus B bar plus C bar plus D bar upon 4. Now we'll see the solved examples. Now the solved example. Find the coordinates of the point which divide the line segment joining the points A 2 minus 6 8 and B minus 1 3 minus 4 internally in the ratio 1 as to 3 and externally in the ratio 1 as to 3. Let A bar and the B bar are the position vectors of the points A and B respectively. Then A bar is equals to, we can write here 2i cap minus 6j cap plus 8k cap. B bar is equals to minus I cap plus 3j cap minus 4k cap. And suppose R bar, that is R is the point which divides the line segment joining the points A and B internally in the ratio 1 as to 3. Then by using the formula, what is that formula? R bar is equals to 1B bar plus 3A bar upon 1 plus 3. That is the MB bar plus NA bar upon M plus N. Now substitute the value of vector B bar. Vector B, that is a minus I cap plus 3j cap minus 4k cap plus 3 in bracket, that is a A bar 2i cap minus 6j cap plus 8k cap. And then you will get, that is a minus I, and here is a plus 6i, then here is a 5i. Next is a 3j and minus 18. You will get minus 15j, and the minus 4 plus 24, you will get 20k cap upon 4. And therefore the coordinate of the point R are 5 by 4 minus 15 by 4 and 20 by 4 is the 5, and this way. Now the next, suppose that S is the point which divides, okay, here is the S is the point which divides the line joining the point A to -6, 8 and B -1, 3, -4 externally in the ratio 1:3. Then we can write S bar is equals to 1B bar minus 3A bar upon 1 minus 3. Now substitute the value of vector B, that is 1 into minus I cap plus 3J cap minus 4K cap minus 3 in bracket 2I cap minus 6J cap plus 8K cap. And if we evaluate it, then you get minus I, and here is a minus 6, then you will get minus 7I cap. 3J and plus 18, then you will get 21J cap. Minus 4K cap and the minus 24, then you will get minus 28K cap upon minus 2. If we divide it, minus 7 upon minus 2, then you will get 7 by 2. 21 upon minus 2 means what? Minus 21 upon 2. And here is a minus, I will repeat again, minus 28 upon minus 2, that is 14. This is a 14. And in this way, we have the coordinate of the point S are 7 by 2, minus 21 upon 2 and 14 in this way. Now the next problem. If the 3 points A, 3, 2, P, B, Q, 8, minus 10, C, minus 2, minus 3, 1 are collinear, then find first the ratio in which the point C divide the line segment AB, and second the values of P and Q. Now first of all, here we want to find out the ratio, then we treat it as K:1, T:1. Anyway, let A, the vector A bar, that is A bar is equals to 3I cap plus 2J cap plus PK cap, and B bar is equals to QI cap plus 8J cap minus 10K cap. C bar is equals to minus 2I cap minus 3J cap plus K cap. Suppose the point C divide the line segment joining AB in the ratio T:1. Then by the section formula, C bar is equals to TB bar plus 1A bar upon T plus 1. And the next is, substitute the value of the point C, which is minus 2I cap minus 3J cap plus K cap, is equals to T in bracket QI cap plus 8J cap minus 10K cap, that is the value of B bar, plus 1 A bar. What is A bar? 3I cap plus 2J cap plus PK cap. And here the cross multiplication, that is therefore minus 2I cap minus 3J cap plus K cap in bracket T plus 1 into T plus 1. And here collect the terms of I, J, K separately. Now the terms of I, that is the TQ, and here is only 3. That is the TQ plus 3 I cap. Next is the J, the terms of the J, that is 8T, and here is 2. That is 8T plus 2J plus, and the last term is minus 10T, and here is a P only. Minus 10T plus P into bracket complete into K cap. And here we will equate this, all this. That is if we take the multiplication of T plus 1 with all the terms containing in this bracket, that is a minus 2 into in bracket T plus 1 I cap minus 3 in bracket T plus 1 J cap plus T plus 1 bracket complete K cap, and collect the terms of I, J and the K. Equate the coefficient of I, J and the K. Now see, this is the first of all, we will equate it. Now the coefficient of I cap, what is here? To the left hand side, minus 2 in bracket T plus 1, and here is a TQ plus 3. Next is a minus 3 into T plus 1, and here is a 8T plus 2. And next is a T plus 1, and here is a minus 10T plus P. And all these three equations, we solve all these equations. Now see this here one by one. The equation number 2, consider this equation number 2. What is that? Minus 3 in bracket T plus 1 is equals to 8T plus 2. We will evaluate it. Minus 3 in bracket T plus 1 is equals to 8T plus 2. Then you will get minus 3T minus 3 is equals to 8T plus 2. And if you simplify it, then you will get minus 3 and minus 2 to the left hand side, and this minus 3t to the right hand side. 8t plus 3t, then you will get 11t. It is equals to minus 5, and that's why t is equals to, here you will get t is equals to minus 5 by 11. Next, put this value of t is equals to minus 5 by 11 in equation number 1, which is minus 2 in bracket t plus 1 is equals to t cube plus 3. Substitute here value of the t, that is a minus 5 by 11, that is minus 2 in bracket minus 5 by 11 plus 1 bracket complete is equals to minus 5 by 11 cube plus 3, and then evaluate it. It can be written as again, therefore minus 2 in bracket 1 minus 5 by 11 is equals to minus 5 by 11 cube plus 3. And if we simplify this, that is a 1 minus, okay, 1 minus 5 by 11, then you will get minus 2 into 6 by 11. And that's equals to minus 5 by 11 cube plus 3. And again, if we simplify it, that is a minus 2 into, what is here, 6, then you will get minus 12 upon 11 minus 3, and that's equals to minus 5 upon 11 cube. And again, if we simplify this, then what you will get, minus, here is a minus 33 and minus 12. You will get minus 45 upon 11 is equals to minus 5 upon 11 cube. 11 get cancelled, and you will get, that is a 45 is equals to 5 cube, and that's why q is equals to 9. Next, put t is equals to minus 5 by 11 in this expression number 3. Then you will get, substitute the value of this t. That is, the t is a minus 5 by 11 plus 1 is equals to minus 10 into in bracket minus 5 by 11 bracket complete plus p. And if you evaluate it, then you will get 1 minus 5 by 11 means what? You will get 6 upon 11, and that's equals to, now minus 10 into minus 5 by 11, then you will get 50 upon 11 plus p. Therefore, 6 upon 11 minus 50 upon 11 is equals to p. And if we evaluate it, that is a minus 44 upon 11, that is a p is equals to minus 4. And in this way, you are getting all the values, that is the t is equals to minus 5 by 11, q is equals to 9, and p is equals to minus 4. The negative sign of the t suggests that the point C divides the line segment AB externally in the ratio 5 as to 11. Now the next problem. Problem number 3. If A 5 1p, B 1q, P C 1 minus 2 3 are vertices of triangle, and G are minus 4 by 3 and 1 by 3 is its centroid, then find the values of P, Q and R. Now the vector A bar, or we can, I will read it as a bar only. A bar is equals to phi I cap plus j cap plus pk cap. B bar is equals to I cap plus qj cap plus pk cap, and C bar is equals to I cap minus 2j cap plus 3k cap, and the G bar is equals to Ri cap minus 4 by 3j cap plus 1 by 3k cap. By the centered formula, what is that centered formula? G bar is equals to A bar plus B bar plus C bar upon 3, and that's why 3G bar is equals to A bar plus B bar plus C bar. Now we'll substitute the value of this G bar, that is a 3 in bracket Ri cap minus 4 by 3 J cap plus 1 by 3 K cap. Okay, 1 by 3 K cap, here I will write here K cap for easy also, and that's equals to A bar plus B bar plus C bar. A bar is a phi I cap plus J cap plus pk cap plus I cap plus qj cap plus pk cap. This is the value of B bar, and the last is a C bar is a I cap minus 2j cap plus 3k cap. Now collect the terms of I, j, k on the both sides. Here is a 5 I cap and 1 I cap and 1 I cap, then you will get 7 I cap. What about the j? Here is a 1j and minus 2j, then you will get minus 1j. And here is a qj, that is a q minus 1 bracket complete j cap plus pk, and here is also 1 pk, that you will get 2 pk cap, and plus here is a 3k cap. If you collect it, then you will get 2p plus 3 bracket complete k cap. Now equate it. Here is also to the left hand side. you will get 3r I cap minus 4 by 3 into 3. Then 3 will get cancelled. You will get minus 4j plus 3 into 1 by 3. Again 3 get cancelled. You will get k cap. Now equate the coefficient of I cap. First equate the coefficient of I cap. That is, a 7 is equals to 3r. Okay. And therefore r is equals to 7 by 3. Next, minus 4 is equals to q minus 1. Minus 4 is equals to q minus 1. And that's why q is equals to minus 4 plus 1. Therefore, q is equals to minus 3. And the last is 1 is equals to, from the left hand side, 1k. And here is a 1 is equals to 2p plus 3. And therefore, you will get here the value of p, that is equals to minus 1. If we simplify, that is a minus 2 is equals to minus 2 is equals to 2p. Therefore, p is equals to 2 upon minus 2. Then you will get p is equals to minus 1. And in this way. Now the next problem. If a bar, b bar, c bar are the position vectors of the point a, b, c respectively, and phi a bar minus 3b bar minus 2c bar is equals to 0, then find the ratio in which the point C divide line segment joining BA. Okay. Now here we have, that is, a 2a bar minus 3b bar minus 2c bar is equals to 0. Therefore, 2c bar is equals to phi a bar minus 3b bar. Therefore, c bar is equals to phi a bar minus 3b bar upon 2. And that's why c bar is equals to phi a bar minus 3b bar. This 2 can be written as phi u minus 3. And this shows that point C divides BA externally in the ratio phi u as to 3. And in this way, we can solve this. Now, the next problem. Prove that the medians of a triangle are concurrent. Now, see this. These are the median. That is a triangle ABC. AD is the first median, then BE, and the last is CF. Concurrent means what? All the medians intersect at a single point, which is the G. Let A, B, and C be the vertices of triangle. A, B, C are the vertices. D, E, and F are the midpoints of the side BC, AC, AB. D is the midpoint of BC, E is the midpoint of AC, and F is the midpoint of AB, respectively. Let A bar, B bar, C bar, D bar, E bar, and F bar be the position vectors of all these points, which are A, B, C, D, E, F, respectively. Therefore, by the midpoint formula, what is their D bar? D bar is equals to B bar plus C bar upon 2. E bar is equals to A bar plus C bar upon 2. And F bar is equals to A bar plus B bar upon 2. And in this way, D bar is equals to B bar plus C bar upon 2. Here is the B bar. Okay. And the next E bar is equals to A bar plus C bar upon 2. And F bar is equals to A bar plus B bar upon 2. Now next, here we simplify. 2 into D, that is a 2D bar is equals to B bar plus C bar. 2 into E, that is a 2E bar is equals to A bar plus B bar. 2F bar is equals to A bar plus B bar. And now consider here, 2D bar is equals to B bar plus C bar. Now which term is absent? To the right hand side, A bar is absent. Therefore, here we will add on the both side A bar. Then you will get 2D bar plus A bar is equals to A bar plus B bar plus C bar. Similarly, for here, which term is absent? B bar is absent. Therefore, add B bar on both sides. Which term is absent here? C bar is absent. Therefore, add C bar on both sides. And hence, here you will get, that is the 2A bar is equals to A bar plus C bar. Then add B bar on both sides. Here, 2A bar is equals to A bar plus B bar. Then which term is absent? C bar is absent. Therefore, 2A bar plus C bar is equals to A bar plus B bar plus C bar. See this here. A bar plus B bar plus C bar is common for all. That is a 2D bar plus A bar is equals to A bar plus B bar plus C bar. 2E bar plus B bar is equals to again A bar plus B bar plus C bar. 2A bar plus C bar is equals to again A bar plus B bar plus C bar. Then equate it. Then you will get 2D bar plus A bar is equals to 2E bar plus B bar is equals to 2A bar plus C bar is equals to A bar plus B bar plus C bar. Now we divide the whole equality by 3. Then what you will get? Therefore 2D bar plus A bar upon 3, 2E bar plus B bar upon 3, 2A bar plus C bar upon 3, and A bar plus B bar plus C bar upon 3, that's equals to G bar. And then we have here, that is a G bar is equals to A bar plus B bar plus C bar upon 3. And this can be written as 2 into D bar plus 1 into A bar. That can be written as 2 plus 1. 2 E bar, again this can be written as 2 into E bar plus 1 into B bar upon 2 plus 1. That's equals to 2 into F bar plus 1 into C bar upon 2 plus 1. If G is the point whose position vector is a G bar, then from the above equation, it's clear that point G lies on all the medians. Means what? Median AD, median B and the median CF. And it divides each of the median AD, B, CF internally in the ratio 2:1. This is the 2 and this is the 1. Therefore, 3 medians are concurrent, means they intersect at a single point. Now the next. Prove that the angle bisector of a triangle are concurrent. Now see this here. The triangle ABC, AD is the angle bisector of angle A. B is the angle bisector of angle B. CF is the angle bisector of angle C. Okay. And all these bisectors are the concurrent, means they intersect at a single point, which is the H. Now we will prove this. This type of theorem you have proved in the 9th standard also. Let A and B, C be the vertices of the triangle. AD, B, CF be the angle bisector of triangle ABC. AD, then B and the CF, these are the angle bisector. Let A bar, B bar, C bar, D bar and E bar and F bar be the position vectors of the points A, B, C, D, E and F respectively. Also, now see this here. The length AB is equals to Z, then BC is equals to X and AC is equals to Y. AB is equals to Z, BC is equals to X and AC is equals to Y. Now the angle bisector AD meets the side BC at the point D. Okay. The angle bisector AD, this angle bisector meets the BC at the point D. Okay. Therefore, the point D divides line segment BC internally in the ratio AB as to AC. This point D divides BC internally in the ratio AB as to AC. But what is the AB? AB is a Z and AC is a Y. That is a Z as to Y. Hence, bisection formula for the internal division, we have D bar is equals to, this Z bar will multiply with C and Y will multiply with this B bar. Therefore, D bar is equals to ZC bar plus YB bar upon Z plus Y. And similarly, E bar, we want to find out this E bar. Now, this point E divides the AC in the ratio AB as to BC. Therefore, Z into C bar and X into A bar. Therefore, E bar is equals to XA bar plus Z, C bar upon X plus Z. What about the F? F divides the AB internally in the ratio Y as to X. And therefore, this F bar is equals to Y into B bar, X into A bar. Therefore, F bar is equals to YB bar plus XA bar upon Y plus X. Now, see this here first. This D bar is equals to ZC bar plus YB bar upon Z plus Y. Now, after simplification, that is a cross multiplication, then you will get that is in bracket Z plus Y, bracket complete D bar is equals to ZC bar plus YB bar. Now, which term is absent there? That is the XA bar is absent there. Therefore, add on both sides XA bar. Then you will, in bracket, you will get Z plus Y, bracket complete D bar plus XA bar is equals to XA bar plus YB bar plus ZC bar. And hence, you will get in bracket here, that is a Z plus Y, bracket complete D bar plus XA bar is equals to XA bar plus YB bar plus ZC bar. And similarly, see this here, E bar is equals to XA bar plus ZC bar upon X plus Z. And then again the simplification you will get in bracket X plus Z bracket complete E bar. Okay. And that's equals to XA bar plus ZC bar. And here is also, that is the Y in bracket Y plus X bracket complete F bar is equals to YB bar plus XA bar. Now which term is absent here? That is the YB bar is absent there. Therefore, add on both sides by YB bar. Which term is absent there? Here is the ZC bar is absent there. Therefore, add ZC bar on both sides and see this here. All these equalities, they have the common one point. Which is the one point? XA bar plus YB bar plus ZC bar. XA bar plus YB bar plus ZC bar, and here XA bar plus YB bar plus ZC bar. Then we will equate it. Then what you will get in bracket Y plus Z bracket complete D bar plus XA bar. Next is a in bracket X plus Z bracket complete D bar plus YB bar, and the last is what is that? In bracket X plus Y bracket complete F bar plus ZC bar, and that all are equals to XA bar plus YB bar plus ZC bar. Now dividing this equality by X plus Y plus Z, then what you will get in bracket here, that is a Z plus Y bracket complete D bar plus XA bar upon X plus Y plus Z, and that's equals to in bracket X plus Z bracket complete D bar plus YB bar upon X plus Y plus Z, and that's equals to again X plus Y bracket complete F bar plus ZC bar, again X plus Y plus Z, and lastly XA bar plus YB bar plus ZC bar upon again here XA bar plus YB bar plus ZC bar upon X plus Y plus Z, and that's equals to H bar. Now we can write here like this. This H bar is equals to what is here? Y plus Z bracket complete D bar plus XA bar, and this X plus Y plus Z can be write in this manner. That is Y plus Z bracket complete plus X. Here that is a X plus Z bracket complete D bar plus YB bar, and again X plus Y plus Z can be written as that is a in bracket X plus Z bracket complete plus Y. That's equals to, and the last is a X plus Y into F bar plus ZC bar. Again X plus Y plus Z can be written as X plus Y bracket complete plus Z. This is the point, that is the H bar divides AD in the ratio, which is the ratio? That is a Y plus Z as to X. B in the ratio, that is a B in the ratio X plus Z as to Y, and the CF in the ratio X plus Y as to Z. Now see this here. Okay, and this shows that the point H is the point of concurrence of angle bisector AD, BE, CF. Angle bisector AD, BE, and the CF point H. Okay, of the triangle ABC. Thus, the angle bisectors of a triangle are concurrent, and H is called the incenter of triangle ABC. Now to the next problem. Now the next problem. Using vector method, find the incenter of the triangle whose vertices are A 030, B 004, C 034. Okay. Here let A bar is equals to 3j cap only j term is present there, and B bar is equals to 3k cap. And what about the C bar? C bar is equals to 3j plus 4k. What about the AB bar? AB bar is equals to B bar minus A bar. This is the B bar, which is the 4k cap. Okay, minus 3j cap. 4k cap minus 3j cap. Or we can write it like this. That is a 3j cap plus 4k cap. AC, C bar minus A bar. Okay, then you will get 4k cap. And BC, C bar minus B bar. And that's equals to 3j. What about their magnitudes? AB, if we take the AB, that is the in root of 3 square plus 4 square. 3 square is a 9 and 4 square is a 16. Total is a 25. Root of 25 is a 5. Therefore, mod of AB bar is equals to 5. What about the AC? AC is equals to 4k cap. And therefore, in root of 4 square means what? 16. Root of 16 is 4. Therefore, mod of AC bar is 4. What about the mod of BC bar? That is the root of 3 square, which is the 9. Therefore, mod of BC bar is equals to 3. If H is the incenter of triangle ABC, then you have to remember this formula. What is that? H bar is equals to mod of BC bar into A bar plus mod of AC bar into B bar plus mod of AB bar into C bar upon mod of BC bar plus mod of AC bar plus mod of AB bar. Now their multiplication. What is the BC bar here? BC is a 3. 3 into A bar. What is the A bar? 3j. Therefore 3 in bracket 3j plus AC. What is the AC? AC is a 4 into B bar. What is the B bar? B bar is a 4k cap. Okay, and the last is a AB. AB is a 5. 5 in bracket 3j plus 4k, and if you simplify it, then you will get 9i plus 16k plus 15i plus 15, sorry here, it's a 3 into 3j, then you will get 9j. Okay, next is a 16k, and here is also j, that is a 15j and plus 20k. If we add it, 9j plus 15j, then you will get here 24, again j here. Okay, 24j, here is also j. Okay, and the what about the k? 16k plus 20k, then you will get 36k cap. Yeah. Okay, divided by 12, and then you will get h bar is equals to 2j cap plus 3k cap, and hence the h is equals to 0, 2, 3. This is the in center of the triangle. Now the next is, in triangle ABC, the position vector of the centroid is given by a bar plus b bar plus c bar upon 3. Position vector of the in center is given by mod of ab bar into c bar plus mod of bc bar into a bar plus mod of ac bar into b bar upon mod of ab bar plus mod of bc bar plus mod of ac bar. And the last is the position vector of orthocenter is given by tan of a into a bar, tan of b into b bar, tan of c into c bar upon tan of a plus tan of b plus tan of c. Okay, now the next is, if 4i cap plus 7j cap plus 8k cap, next is a 2i cap plus 3j cap plus 4k cap, and 2i cap plus 5j cap plus 7k cap are the position vectors of the vertices A, B and C respectively of triangle ABC. Find the position vector of the point in which the bisector of angle A meet BC. Okay, here A bar is equals to 4i cap plus 7j cap plus 8k cap. Second is B bar is equals to 2i cap plus 3j cap plus 4k cap. C bar is equals to 2i cap plus 5j cap plus 7k cap. We will find out the AC bar, C bar minus A, C bar minus A bar. That is 2i cap minus 2j cap minus k cap. You can find out it. This C bar minus A bar, then you will get 2i minus 4i, then you will get minus 2i. Next is a 5j minus 7j minus 2j, and 7k minus 8k, then you will get minus. In this way, AB bar is equals to B bar minus A bar, and that's equals to minus 2i cap minus 4j cap minus 4k cap. Find out the value of AC. That is, mod of AC bar is equals to 2 square means 4 plus 2 square into 2 square means 4 minus 1 square is a 1, 4 plus 4, that is 8 plus 1, 9. Root of 9 is 3 in it. Next is a mod of AB bar, and that's equals to again in root of 2 square means 4 plus 4 square is a 16 plus 4 square is a 16. Then what you will get? 16 plus 16, that is a 32. 32 plus 4, 36, and the root of 36 is a 6. Therefore, mod of AB is equals to 6 unit. That we want to find out. Yes, see this here. We want to find out AC and the AB also, because we want to find out the position vector of the point D, which is the angle bisector of the angle A. Okay, let D be the point where the angle bisector of angle A meets the BC. D divides the BC, okay, in the ratio ABS to AC. This D divides BC in the ratio ABS to AC. Therefore, D bar is equals to mod of AB bar. Here is the mod of AB bar into C bar plus mod of AC bar into B bar. Okay, substitute the value of mod of AB bar. Mod of AB bar, that's equals to 6, and the C bar. What is the C bar here? C bar is a 2i cap plus 5j cap plus 7k cap. Here is, okay, all have the cap also here. Okay, plus 3 is 3 into B bar. What is the B bar here? The B bar is a 2i cap plus 3j cap plus 4k cap upon 6 plus 3. That is the mod of AB bar plus AC bar. That is the m as to n. 6 plus 3. And if you simplify it, Then what you will get? 6 into 2, that is a 12 I cap. 6 into 5, 30 j cap. 6 into 7, 42 k cap. Plus 6 into I cap. Sorry, 3 into 2, that is a 6 I cap. 3 into 3, 9 j. 3 into 4, 12 k cap. Add it. 12 I plus 6 j, then you will get 18 I cap. 30 j plus 9 j, then 39 j. 42 k cap, and here is a 12 k cap. Then you will get 54 k cap upon 9. And if you divide it, that is 18 upon 9, you will get 2i. 39 upon 9, then you will get 13 upon 3 j cap. 54 upon 9 k cap, then you will get 6 k cap. And this is the position vector of the point D. And in this way we can solve this. Now the next problem. If G A2 minus 1 is the centroid of the triangle with the vertices P 1, 3, 2 and Q 3, P minus 4 and R 5, 1, C, then find the values of A, B and C. Okay. As G is the centroid of triangle PQR, then G bar is equals to P bar plus Q bar plus R bar upon 3. Now what is the centroid? That is a G A2 minus 1. That is a A I cap plus 2J cap minus K cap. And then you will get P bar plus Q bar plus R bar upon 3. The P bar is a I cap plus 3J cap plus 2K cap plus Q is a 2I cap plus BJ cap minus 4K cap plus, and the last is a 5I cap plus J cap plus CK cap upon 3. Collect the terms of R. Here is the first 1I, 3I and the 5I. 1 plus 3 plus 5 I cap. What about the J? 3 plus B plus 1 J cap. What about the C? 2 minus 4. Okay. Is the 2 minus 4 plus C bracket complete K cap. And if we add it, that is 1 plus 3 plus 5, 9 I cap. Next is a 3 plus 1, 4 plus B bracket complete J cap. And the next is a C minus 2 bracket complete K cap upon this upon 3. Split up it. That is a 9, simplify it. 9 I cap upon 3. Then you will get 3 I cap. In bracket 4 plus B J cap upon 3. That is in bracket 4 plus B bracket complete J cap upon 3. Next is a C minus 2 K cap upon 3. Then equate it. After equating, then you will get what is here? That is a AI cap is equals to 3I cap. Therefore, A is equals to 3. It's a clear. What about the next? Coefficient of J cap on both sides. That is a 2 is equals to 4 plus B upon 3. 4 plus B upon 3. Simplify it. 2 into 3 is a 6. 6 is equals to 4 plus B. And that's why B is equals to 2. Next is a minus 1 is equals to C minus 2 upon 3. And then after simplification, here is a minus 1 into 3 minus 3 is equals to minus 2 plus C. And that's why C is equals to minus 1. And these are the values of A, B, C. A is equals to 3, B is equals to 2 and C is equals to minus 1. And in this way. Now the next problem. Find the centroid of tetrahedron with the vertices. A is a 3 minus 5, 7 and B is a 5, 4, 2. C is a 7 minus 7 minus 3 and the D is a 1, 0, 2. Now the vector A, position vector A, 3I cap minus 5J cap plus 7K cap. B bar is equals to 5I cap plus 4J cap plus 2K cap. C bar is equals to 7I cap minus 7J cap minus 3K cap. And D bar is equals to I cap plus 2K cap. Be the position vectors of the vertices A, B, C and D by the centroid formula. That is a G. G bar is equals to A bar plus B bar plus C bar plus D bar upon 4. Add all these vectors. That is the first is 3I cap minus 5J cap plus 7K cap plus B bar 5I cap plus 4J cap plus 2K cap plus C bar, that is a 7I cap minus 7J cap minus 3K cap plus D bar, that is a I cap plus 2K cap. Collect the terms of I, that is a 3 plus 5 plus 7 plus 1. Next is the collect the terms of J, minus 5 plus 4 minus 7, okay, and then 0. And the next is a K, 7 plus 2 minus 3 plus 2. and then you will get, that is a 3 plus 5 plus 7 plus 1, that is a 69 cap, minus 5 plus 4 minus 7, then you will get minus 8j cap, and the last is a 7 plus 2 minus 3 plus 2, then you will get 8k cap upon 4, and if you divide it or simplify it, then you will get 4i cap minus 2j cap plus 3k cap, and therefore the centroid of the tetrahedron G is 4 minus 2 and 2. Now the next problem. Find the ratio in which P divides AB and the CD, where this is the P divides AB and the CD, where the coordinates of the point A are 2, minus 3, 4, B is 0, 5, 2, C is minus 1, 5, 3, and the D is 2, minus 1, 3. Also find its a coordinate. Okay. Now the solution. Let P divides AB in the ratio m as to n. P divides AB in the ratio m as to n. Also P divides CD in the ratio n as to 1. CD in the ratio n as to 1. The coordinate of the point A are 2, minus 3, 4, and the B is 0, 5, 2. C is minus 1, 5, 3, and the D is 2, minus 1, 3. Then by using the section formula, first of all, P divides AB in the ratio m as to 1. Then we have, that is, we write always here mx2 plus nx1 upon m plus n in this manner. And therefore, first is, we have here, these are the 2 points. This is the A and the B. First is mx2, means what? M into 0, plus nx1, that is 1 into 2. It is 1 into 2, upon m plus n, means what? M plus 1. Next is a my2. What is y2 here? This is a m into 5 minus. Here is the coordinate of the sign of the 3 is minus 3. Therefore, minus 1 into 3 upon m plus 1. And the last is a m into 2. Means what? M into 2 plus 1 into 4. Here upon m plus n. And if you simplify it, this will become 0. 1 plus 1 into 2. Then you will get, that is a 2. 2 upon m plus 1. Next is a 5m. If we simplify here, this is first one, 5m minus 3. Here is a 5m minus 3 upon m plus 1. Next is a 2m plus 4. Here is a 2m plus 4 upon m plus 1. Now the next is, point P divides CD in the ratio n as to 1. Therefore, first is a CD. Here is a CD, and all these points of the C are x1, y1, z1, and the D are x2, y2, z2. The first is n into x2. But what is x2 here? x2 is a 2. Therefore, n into 2 plus 1 into x1. x1 is a minus 1. And similarly, we have here, that is a n into 2 plus 1 into minus 1. Then you will get, that is a 2n minus 1 upon n plus 1. Next is, what is that? my2. What is the y2 here? y2 is minus 1. We'll make some correction in this problem. There is a coordinate of the y coordinate of the point D must have the plus sign. Okay, here is a plus sign, and then you will get the correct one. That is a n into 1. Okay, n into 1, that is the n, and next 1 into 5, 1 into 5 upon n plus 1. Next is about the z. What is that? n into 3, n into 3 plus 1 into 3 plus 1 into 3 upon n plus 1. And again, if you simplify here, you will get 2n minus 1 upon n plus 1. Next is n plus 5 upon n plus 1. 3n plus 3 upon n plus 1. Now equate all these points. This is first is a x, these are the y, and the last is z. First we will equate the z coordinates. What is the z coordinate here of the point P? Here is a 2m plus 4 upon n plus 1. Here is a 3n plus 3 upon n plus 1. If we equate it, the coordinate, z coordinate, then what you will get? 2m plus 4 upon m plus 1. Next is a 3n plus 3 upon n plus 1. Take 3 as a common. You will get in bracket n plus 1 upon n plus 1. If you simplify, then you will get 3. It means that 2m plus 4 upon m plus 1 is equals to 3. Make the cross multiplication. Then what you will get? That is that 2m plus 4 is equals to 3 in bracket m plus 1. That is that 2m plus 4 is equals to 3m plus 3. And again if we simplify, that is a 3m minus 2m, then you will get m. Next is a 4 minus 3. You will get 1. The value of m is equals to 1. Now equating the x coordinate. What is the x coordinate? 2 upon m plus 1. Next is a 2n minus 1 upon n plus 1. Put m is equals to 1. Substitute m is equals to 1. That is a 2 upon 1 plus 1. 2 upon 1 plus 1 is 2. 2 upon 2 is 1. That is 1 is equals to 2n minus 1 upon n plus 1. Make the cross multiplication. And therefore you will get n plus 1 is equals to 2n minus 1. And again if you simplify, that is a 2n minus n. And here to the left hand side, 1 plus 1, that is 2. Therefore n is equals to 2. If you simplify, then here you will get n is equals to 2. Therefore P divides AB in the ratio m as to 1. But what is the value of m? M is 1. That is the ratio is 1 as to 1. What about the CD? That is the P divides CD in the ratio n as to 1. But what is the value of n? N is 2, which is a 2 as to 1. And in this way we can find out the coordinate of the point P also. What is the coordinate of the point P? This is the 2 upon m plus 1, 5m minus 3 upon m plus 1, 2m plus 4 upon m plus 1. Substitute the value of m. Then you will get here, okay, the 2m is 1. That is the 2 upon 1 plus 1. Next is a 5 minus 3 upon 1 plus 1. 2 plus 4 upon 1 plus 1. Then you will get 2 by 2, 2 by 2, 6 by 2. Then you will get 1, 1, 3. And in this way, we have the coordinate of the point P. Now the next problem. The problem number 12. In a triangle ABC, D and E are the points on BC and AC respectively, such that BD is equals to 2 times DC and A is equals to 3 times EC. Let P be the point of intersection of AD and the BE. Then find the ratio BP as to PF using the vector method. Very nice problem. Now see this here. Again I will repeat the problem. That is, the point D and E are the point on BC and AC such that BD is equals to 2 times DC. That is the D divides BC in the ratio 2 as to 1. See this here. Let A bar, B bar, C bar be the position vector of A, B, C respectively with respect to some origin. D divides BC, this D divides BC in the ratio 2 as to 1, and E divides AC in the ratio 3 as to 1. Therefore D bar is equals to, by using the section formula, 2 into C bar plus 1 into B bar. Therefore D bar is equals to B bar plus 2C bar upon 3. And what about the E bar? E bar is equals to 3C bar plus 1A bar. E bar is equals to A bar plus 3C bar upon 4. That is 1 plus 3. That is 4. These are the position vectors of the point D and E. Let point of intersection P of AD and the BE. P is the point of intersection of AD and the BE. This is the AD and the BE. They intersect at the point P. Now, the point P divides BE in the ratio K as to 1. Therefore, we will find out the coordinate of the point P. Therefore, K into E bar. Okay, K into E bar. But what is the coordinate of the point E? E has the coordinate A bar plus 3C bar upon 4. Therefore, we multiplied here K in bracket A bar plus 3C bar upon 4. And 1 into, here is a B bar. That is a B bar. Similarly here, the point P divides AD internally in the ratio M as to 1. And therefore, this P bar is equals to m into this d bar. But what is the d bar? D bar is a b bar plus 2c bar upon 3. Therefore, m in bracket b bar plus 2c bar upon 3 and plus, what is there? 1 into a bar. This is 1 into a bar. This is very important. Okay. Now, we'll simplify this. Okay. The coordinates of these 2 points are equal and then equate it. Then you will get correct answer. Then equating the position vector of P, we get the position vector of P in these 2 cases. Therefore, P bar is equals to A bar plus M in bracket B bar plus 2C bar upon 3 upon M plus 1. And that's equals to B bar plus K in bracket A bar plus 3C bar upon 4 upon K plus 1. And if we simplify it, that is a 3 into A bar, 3A bar plus M in bracket B bar plus 2C bar upon 3 in bracket M plus 1. And that's equals to 4B bar plus K times A bar plus 3C bar upon K in bracket K plus 1. Now equate all these points. What is here? That is a 3A bar upon 3 in bracket M plus 1 plus MB bar upon 3 in bracket M plus 1 plus 2MC bar upon 3 in bracket M plus 1. And to the right hand side, here is again the K bar. K bar upon K in bracket 4 in bracket K plus 1. Next is a 4B bar upon 4 in bracket K plus 1. That 4 will get cancelled. And you will get B bar upon K plus 1 plus the last is a 3C bar, that is a into K upon 4 in bracket K plus 1 here. And then if you simplify it, then you will get here, that is the 3A bar upon 3 in bracket M plus 1 is equals to equate. Here is the coefficient of A bar, B bar and the C bar. 3A bar upon 3 in bracket M plus 1. Here is a K bar upon 4 in bracket K plus 1. Equate it. First A bar. Next is a B bar. MB bar upon 3 in bracket M plus 1. And that's equals to 1B bar upon K plus 1. And the last is 3MC bar. Here is a 3MC bar upon 3 in bracket M plus 1. And that's equals to 3KC bar upon 4 in bracket K plus 1. Now K bar get cancelled on both sides. 3 get cancelled. Here to the left hand side you will get 1 upon M plus 1. And here K upon 4 in bracket K plus 1. What about here? Again a B bar get cancelled. You will get M upon 3 in bracket M plus 1. And that's equals to 1 upon K plus 1. And the last is again here, that is a C bar get cancelled. And then you will get 2M upon 3 in bracket M plus 1. And that's equals to 3K upon 4 in bracket K plus 1. Now we will simplify one by one. See this here, this is the first equation, this is the second and the last is third one. Now divide the third, this is the third, by the second. If we divide, that is a 2M upon 3 in bracket M plus 1. Left hand first of all. This is divided by, which is that term? That is a M upon 3 in bracket M plus 1. And that's equals to, again, 3K upon 4 in bracket K plus 1. It is divided by 1 upon K plus 1. Then you will get here, what terms will get cancelled? That is a M plus 1 get cancelled, M get cancelled. Again, 3 get cancelled, and only the term remaining from the left hand side is only 2 here. Okay, and to the right hand side, again K plus 1 get cancelled. Okay, and you will get here only 3K upon 4. Here is a 3K upon 4. And therefore K is equals to 8 upon 3. This is the K is equals to 8 upon 3. And therefore, what about the ratio? That is we want to find out the ratio BP as to PE. It's a K as to 1. And therefore BP as to KE is equals to K as to 1. And that is nothing but 8 as to 3. And this we want to find out it. Now we will start the exercise 5.2. Exercise 5.2. Find the position vector of point R which divide the line joining the points P and Q whose position vectors are 2i cap minus j cap plus 3k cap and minus 5i cap plus 2j cap minus 5k cap in the ratio 3:2. First internally and the next is externally. Now the solution. It is given that the points P and Q have the position vector that is 2i cap minus j cap plus 3k cap and the q bar is equals to minus 5i cap plus 2j cap minus 5k cap respectively. Internally, if R bar divides the line segment PQ internally in the ratio 3:2, then by the section formula for the internal division, that is R bar is equals to 3Q bar plus 2P bar upon 3 plus 2. Okay, and then substitute the values. Then you will get the value of Q bar and the P bar. Therefore, R bar is equals to, here is R bar is equals to 3 in bracket Q bar minus 5i cap plus 2j cap minus 5k cap plus 2 in bracket 2i cap minus j cap plus 3k cap bracket complete upon 3 plus 2 and that's 5. Here after simplification you will get 3 into minus 5 minus 15 plus 4, then you will get minus 11i cap. Next is a 6j and here is a minus 2j, 4j and the minus 15 and plus 6, then you will get 9k cap upon 5 and that's why 1 by 5 in bracket minus 11k I cap plus 4j cap minus 9k cap, and therefore the coordinate of R is minus 11 upon 5, 4 by 5 minus 9 by 5. Hence the position vector of R is 1 by 5 in bracket minus 11i cap plus 4j cap minus 9k cap, and the coordinate of the point R minus 11 upon 5, 4 by 5 minus 9 by 5. Now the externally, for the external division, that is the P bar is equals to again 2i cap minus j cap plus 3k cap and the Q bar is equals to minus 5i cap plus 2j cap minus 5k cap. If R divides the line segment joining P and Q externally in the ratio 3:2, then by the section formula for the external division, R bar is equals to 3Q bar minus 2P bar upon 3 minus 2. Therefore, for the formula for the external division, R bar is equals to 3Q bar minus 2P bar upon 3 minus 2. That is a 3 in bracket again 5 minus 5i cap plus 2j cap minus 5k cap minus 2 in bracket 3i cap minus j cap plus 3k cap upon 3 minus 2. And after simplification, then you will get minus 15 plus 6j cap minus 15k cap minus 4i cap plus plus 2j cap plus 6k cap, and if we add it minus 15i cap and minus 4i cap, then you will get minus 19i cap. What about the j? 6j plus 2j, then you will get 8j. Next is a minus 15k cap and plus 6k cap. I will make here small again correction, that is a minus 15i cap, minus 15i cap minus 4i cap, then you will get minus 19i cap. What about the j? 6j plus 2j, then you will get 8j. Next is a minus 15k cap and minus 6k cap, then you will get minus 21k cap, and therefore the coordinate of R, that is a minus 19, 8 and minus 21. Hence the position vector of R is a minus 19i cap plus 8j cap minus 21k cap, and the coordinate of R minus 19, 8 and minus 21. Okay. Now the next problem. Find the position vector of midpoint M joining the point L 7 minus 6 12 N 5 4 minus 2. The position vector L and N, L bar and the N bar of the point L 7 minus 6 12 and N 5, 4 minus 2 r. L bar is equals to 7i cap minus 6j cap plus 12k cap. N bar is equals to 5i cap plus 4j cap minus 2k cap. If M is the midpoint of Ln, then by the midpoint formula, M bar is equals to L bar plus N bar upon 2. And then you will get 7i cap minus 6j cap plus 12k cap plus in next bracket 5i cap plus 4j cap minus 2k cap upon 2. And then if we add it, then you get 7i plus 5i, then you get 12i, minus 6j plus 4j, then you get minus 2j, 12k cap minus 2k cap, then you will get 10k cap. Divide by 2, then you will get M bar is equals to 6i minus j plus 5k cap. And therefore the coordinate of the point M are 6 minus 1, 5. Hence the position vector of M is a 6i cap minus j cap plus 5k cap, and the coordinate of the point M are 6 minus 1 and 5. Next, problem number 3. See this here. If the point A 3, 0, P, B minus 1, Q, 3, C minus 3, 3, 0 are collinear, then find the ratio in which C divides the line segment AB. Second, the values of P and Q. The first of all, let A bar, B bar, C bar be the position vector of A, B and C respectively. Then A bar is equals to 3i cap plus 0j cap plus pk cap. B bar is equals to minus I cap plus qj cap plus 3k cap. C bar is equals to minus 3i cap plus 3j cap plus 0k cap. As the point A, B, C are collinear, suppose the point C divides the line segment AB in the ratio lambda is to 1. Then C bar is equals to lambda B bar plus 1 A bar upon lambda plus 1. And therefore you will have here C bar. What is the position vector of the C bar? That is a minus 2i cap plus 3j cap plus 0k cap. That is a lambda in bracket B bar. The B bar is a minus I cap plus qj cap plus 3k cap plus A bar. A bar is a 3i cap plus 0j cap plus pk cap upon lambda plus 1. And that's why you will get here there after simplification, that is a therefore lambda plus 1 in bracket minus 3i cap plus 3j cap plus 0k cap, and that's equals to lambda. If you multiply it with lambda, then you will get minus lambda I cap plus lambda q j cap plus 3 lambda k cap plus 3i cap plus 0j cap plus pk cap. Collect the terms of I cap on the both sides. Okay, from the left hand side, that is a minus 3 in bracket lambda plus 1 I cap plus 3 in bracket lambda plus 1 j cap plus 0 into k cap. Okay, and here to the right hand side, minus lambda I cap, and here is a 3i cap. That is a in bracket minus lambda plus 3 I cap plus lambda q j cap and plus 3 lambda k cap, and here pk cap. That is a take the common as k cap. Then in bracket 3 lambda plus p. Equate the coefficient of I cap, j cap and k cap from the both sides. That is the equality of the two vectors. That is first of all I cap. What is here the coefficient of I cap? Minus 3 in bracket lambda plus 1. And on the right hand side minus lambda plus 3. Now simplify this. That is a minus 3 lambda. Minus 3 is equals to minus lambda plus 3. Here minus 3 lambda take to the right hand side. Then you will get, or to the left hand side, minus 3 lambda plus lambda. Then you will get minus 2 lambda. Plus 3 and plus 3, that will become 6. Minus 2 lambda is equals to 6, and therefore lambda is equals to 3. Next is the coefficient of j on the both sides. That is to the left hand side 3 in bracket lambda plus 1, and to the right hand side lambda cube. We know the value of lambda, which is minus 3. That is a 3 in bracket minus 3 plus 1 is equals to minus 3 cube. And again here we get it minus 3 plus 1 minus 2 into 3 minus 6 is equals to minus 3 cube, and therefore q is equals to 2. We know the value of q and the lambda. And the last, that is the coefficient of k. To the left hand side it is a 0, and to the right hand side it is a 3 lambda plus p. Substitute the value of lambda, which is the minus 3. That is 0 is equals to 3 in bracket minus 3 plus p. That is 0 is equals to minus 9 plus p, and therefore p is equals to 9. Therefore the C divides AB externally in the ratio 3:1, and also the value of P is 9 and Q is 2. C divides AB externally in the ratio 3:1. It means that the value of lambda is minus 3 and the ratio is lambda as to 1, and therefore we treat as it is externally and in the ratio 3:1. Now the next problem. The position vectors of point A and B are 6A bar plus 2B bar and A bar minus 3B bar. Okay. The point C divides AB in the ratio 3:2. Then show that the position vector of C is 3A bar minus B bar. Let C be the position vector of the point C. Since C divides AB in the ratio 3:2. Okay. A and B are, what is the position vector of A and B? That is a 6A bar plus 2B bar, and the B is A bar minus 3B bar. Now C bar is equals to 3 in bracket. This C divides in the ratio 3:2. Then 3 will multiply to the B. Therefore C bar is equals to 3 in bracket A bar minus 3B bar plus 2 into A bar. That is the position vector of the point A, which is the 2 in bracket 6A bar plus 2B bar upon 2, 3 plus 2. Okay, and if you simplify it, that is a 3 into A, 3A bar, 3 into 3B bar minus 9B bar plus 12A bar and plus plus 4B bar, and if we add it and 3 plus 2, that is a 5. Collect the terms of A bar, 3A bar plus 12A bar, 15A bar minus 9B bar plus 4B bar, and then you will get minus 5B bar upon 5. Divide it by 5, then you will get 1 upon 5 in bracket 15A bar minus 5B bar. Here you will get C bar is equals to 3A bar minus B bar. Hence the position vector of C is 3A bar minus B bar. Now the next problem. Prove that the line segment joining the midpoint of adjacent sides of quadrilateral form a parallelogram. You take any quadrilateral. That is, here ABCD is a quadrilateral, and PQRS, these are the midpoints of AB, BC and the CD and AD. Okay, and the quadrilateral form, which is that PQRS, then it is a parallelogram. Now we want to prove this. Let ABCD be a quadrilateral and the PQRS be the midpoints of AB, BC, CD and the last is AD. Here I will write AD. Okay, now I will again repeat here. Let ABCD be a quadrilateral and the PQRS be the midpoints of the side AB, BC, CD and AD respectively. Let A bar, B bar, C bar, D bar, Q bar, P bar, Q bar, R bar and the S bar be the position vectors of the points A, B, C, D, P, Q, R and S respectively. Since P, Q, R and S are the midpoints of side AB, BC, CD and DA respectively. Since P, Q, R and S are the midpoints of the sides AB, BC, CD, DA respectively. Then what about the P bar? P bar is nothing but the B bar plus A bar plus B bar upon 2. Q bar is a B bar plus C bar upon 2. R bar is a C bar plus D bar upon 2. And S bar is a D bar plus A bar upon 2. Now we find out the first of all PQ bar. PQ bar is equals to Q bar minus B bar. The value of Q bar is a B bar plus C bar upon 2 minus P A bar plus B bar upon 2. Take 1 upon 2 as a common, then in bracket you will get B bar plus C bar minus A bar minus B bar. That is a 1 upon 2. Here what will get cancelled? That is a plus B bar minus B bar get cancelled. and then you will get 1 upon 2 in bracket C bar minus A bar. This is the PQ bar is equals to 1 upon 2 in bracket C bar minus A bar. And therefore, next is the SR bar. That is the R bar minus S bar. The position vector of the R bar is a C bar plus D bar upon 2. And the S bar is a D bar plus A bar upon 2. Take the 1 upon 2 as a common. Then in bracket you will get C bar plus D bar minus D bar and minus A bar. If you open the bracket, the negative sign is outside the bracket. And here again, which term will get cancelled? That is the plus D bar and minus D bar get cancelled. And then therefore you will get SR bar is equals to 1 upon 2 C bar minus A bar. Now what's happening here? That we get here PQ bar is equals to, here is the PQ bar. PQ bar is equals to 1 up. PQ bar is equals to SR bar. That is 1 upon 2 C bar minus A bar. And SR bar is also 1 upon 2 C bar minus A bar. Now we know the definition of the parallelogram. That is the P bar is and the S bar. That is the vector PQ bar is equals to vector SR bar. That is the PQ bar is equals to SR bar. And therefore they are parallel. Therefore PQ bar is a parallel to. Here we have PQ bar and the SR bar both are the same, as well as they are the parallel, and therefore similarly that is the PQ bar is a parallel to SR bar. They are equal in magnitude and both of them have the same direction. Therefore they are parallel. Similarly we can prove that is a QR bar is a parallel to PS bar, and therefore when the opposite sides of a quadrilateral are parallel, then it is called the parallelogram, and that's why PQRS is a parallelogram. Now the next is again very nice problem. D and E divides BC and CA of triangle ABC in the ratio 2:3 respectively. Find the position vector of the point of intersection of AD and BE and the ratio in which this point divides AD and BE. Let AD and the BE intersect at P. AD and the BE intersect at the point P. Let AB, CD, E, P have the position vectors A bar, B bar, C bar, D bar, E bar, P bar respectively. D and E divides BC. D and E divides BC ACA internally in the ratio 2:3. Therefore bisection formula. D bar is equals to, this is 2 and 3. 2 into C bar plus 3 into B bar. 2 into C bar plus 3 into B bar upon 2 plus 3. Therefore 2 plus 3 is 5, and after simplification then you will get that is the 5D bar is equals to 2C bar plus 3B bar. Next is the E bar. Then again 2 into A bar plus 3 into C bar. Then you will get E bar is equals to 2A bar plus 3C bar upon 2 plus 3. 2 plus 3 is again 5. 5E bar is equals to 2A bar plus 3C bar. Now consider first one. That is the 5D bar is equals to 5D bar is equals to 2C bar plus 3B bar. Now multiply this equation by 3. Now we simplify it. If you multiply it by 3, then you will get 5 into 3 is a 15D bar minus 9B bar, and that's equals to 6C bar. And the from 2, what's here? 5E bar is equals to 2A bar plus 3C bar. And it can be again written as, that is again here 5E bar minus 2A bar is equals to 3C bar. Okay. Now multiply this equation by 2. Then you will get 10E bar minus 4A bar is equals to 6C bar. And equating now the coefficient of C bar here. Now in first case we have 6C bar is equals to 15D bar minus 9B bar. And in second case we have here that is a 10E bar minus 4A bar is equals to 6C bar. And here we get that is a, after equating 15D bar minus 9B bar is equals to 10E bar minus 4A bar, and after simplification Here you will get 15 d bar plus 4a bar, and that's equals to 10 e bar plus 9 b bar. And if we divide, that is 15 plus 4 is 90 and 10 plus 9 is a 90. If we divide this equality by the 9, then what will tells LHS? That is, in LHS is the position vector of the point which divides segment AD internally in the ratio 15:4. LHS. This is the, that is a P divides AD in the ratio 15:4. And what about the RHS? RHS is the position vector of the point which divides BE. Okay, this P divides the BE in the ratio 10:2. Here is a P divides BE in the ratio 10:9. But P is the point of intersection of AD and DE. P is a point of intersection of AD and the DE. And therefore P divides AD. This P divides AD internally in the ratio 15:4. Also P divides B internally in the ratio 10:9. And hence the position vector of the point of intersection of AD and the BE is P bar is equals to, that is a 15 d bar plus 4a bar upon 19, and that's equals to 10 e bar plus 9 b bar upon 19, and it divides AD internally in the ratio 15:4 and the BE in the ratio 10:9, and in this way we get the answer. I will show you once again. This is the, okay, and this is the figure that was overlapping on this matter. Okay. Now the next problem. Prove that a quadrilateral is a parallelogram if and only if its a diagonal bisect each other. All these properties you have proved in the 9th standard. The first is if part. Let first we consider this quadrilateral ABC as a parallelogram, then we say that we prove that its a diagonal bisect each other. Let A bar, B bar, C bar and D bar be the position vectors of the vertices A, B, C and D of the parallelogram ABCD. Then AB is equals to DC. AB is equals to DC, and AB bar is a parallel to DC bar. No problem, because the opposite sides of the parallelogram are congruent and as well as they are parallel. AB bar is equals to DC bar. Therefore, AB bar means what? B bar minus A bar. And DC bar means what? C bar minus D bar. And again this can be written as, collect the terms of positive sign on one side. That is A bar plus C bar is equals to, rearranging the terms, A bar plus C bar is equals to B bar plus D bar. Divide on both sides by 2. Then you will get A bar plus C bar upon 2 is equals to B bar plus D bar upon 2. This is the first one. The position vector of the midpoints of the diagonal AC and BD are A bar plus C bar upon 2 and B bar plus D bar upon 2, and therefore by 1 they are equal. That is, the midpoint of the diagonal AC and the BD are the same. Therefore, the midpoints of the diagonal AC and the BD are the same, and this shows that the diagonal AC and the BD bisect each other. This is the first part, E part. Now conversely, in converse part, what we prove that if the diagonal bisect of any quadrilateral, then that quadrilateral is nothing but the parallelogram. Converse part, suppose that the diagonal AC and the BD of the quadrilateral ABCD bisect each other. That is, they have the same midpoint there. Therefore, the position vectors of these midpoints are equal. That is A bar plus C bar upon 2. And next is a B bar plus D bar upon 2. And after simplification, you will get a bar plus c bar is equals to b bar plus d bar. And therefore b bar minus a bar, rearranging the terms, b bar minus a bar is equals to c bar minus d bar. But what is a b bar minus a bar? That is ab bar. And c bar minus d bar, that is a dc bar. It means that the AB bar is a parallel to DC bar. AB bar is a parallel to DC bar. And their magnitudes are also equal. And therefore the sides AB is a parallel to DC and the AB is equals to DC. And that's why the quadrilateral ABCD is a parallelogram. Okay, this you can see this also here. Now the next problem. Prove that the medians of a trapezium is parallel to parallel sides of the trapezium and its length is half the sum of the parallel sides. Here in this figure, that is a ABCD is a trapezium, M and N are the midpoints of the side AB and DC. Now see this here. Let A bar, B bar, C bar and D bar be respectively the position vectors of the vertices A, B, C and D of the trapezium. ABCD, that trapezium, with the side AD is a parallel to BC. In this figure, AD is a parallel to BC. Then the vectors AD bar and the BC bar are parallel. AD bar and they are parallel. As they are parallel, then according to our definition, when the two vectors are parallel, then one vector can be expressed as the scalar multiple of the other. Therefore, AD bar is equals to K times BC bar. And that's why here we write AD bar is equals to K times BC bar. Now, in this equality, add on both sides BC bar. Therefore, AD bar plus BC bar is equals to K times BC bar plus BC bar. Take BC bar as a common. Then in bracket, therefore you will get AD bar plus BC bar is equals to in bracket K plus 1 bracket complete BC bar, and this is the first one. Let M bar and the N bar be the position vectors of the midpoints M and N of non-parallel sides. These are the non-parallel sides and M and N are their midpoints of the sides AB and the DC respectively. Then the segment MN is the median of the trapezium. Then by the midpoint formula, what about the M bar? M bar is equals to A bar, M bar is equals to A bar plus B bar upon 2 and the N bar is equals to D bar plus C bar upon 2. Again, what is the Mn bar? Mn bar is the N bar minus M bar. But the value of N bar is a D bar plus C bar upon 2 minus in bracket A bar plus B bar upon 2. And if we collect the 1 upon, if we take the 1 upon 2 as a common, that is we simplify it. Then what you will get? D bar plus C bar minus A bar minus B bar. And rearrange the terms, that is a D bar minus A bar plus C bar minus B bar. But what is the D bar minus A bar? That is the AD bar. And what is the C bar minus B bar? That is the BC bar, which is upon 2. But what is the AD bar plus BC bar? AD bar plus BC bar, we know that AD bar plus BC bar is equals to in bracket K plus 1 into BC bar. And therefore Mn bar is equals to in bracket K plus 1 into BC bar upon 2. It means that the Mn is a scalar multiple of the BC. Mn is a scalar multiple of the BC. It means that Mn is a parallel to BC. But the BC is a parallel to AD. Means that all these three are the parallel. That is the Mn is a, therefore Mn is a parallel to, Mn and BC are the parallel vectors. Mn bar is a parallel to BC bar and where AD bar is also parallel to, BC bar is a parallel to AD bar. Therefore the median Mn is a parallel to the parallel sides AD and the BC of the trapezium. Now AD bar and the BC bar are the collinear. Therefore they can be written as AD bar plus BC bar. Mod of AD bar plus BC bar, that's equals to mod of AD bar plus mod of BC bar. And that is equals to AD plus BC. And therefore from 2, here is the from 2. We have here, that is the AD bar, mod of AD bar plus mod of BC bar is equals to AD plus BC. And therefore Mn bar is equals to, from the 2, we have AD bar plus BC bar upon 2. And that's why Mn is equals to 1 upon 2 AD plus BC. That is the length of MN is equals to half of the sum of its parallel sides. And hence the median MN is the parallel to the parallel sides AD and the BC. And its length is that MN is equals to 1 upon 2. Sum of its parallel sides. That is the AD plus BC. Now the next problem. If two of the vertices of triangle are A 3, 1, 4, B minus 4, 5, minus 3 are, and the centroid of the triangle is given. What is that centroid? G is a minus 1, 2, 1. Then find the coordinate of the third vertex C of the triangle. Means what? In triangle ABC, we know that the coordinate of A, B. We want to find out the coordinate of C. That is, considering that the centroid of the coordinate of the centroid is given. Let us now solve this. Let A bar, B bar, C bar and the G bar be the position vectors of A, B, C and G respectively. Then A bar is equals to 3i cap plus j cap plus 4k cap from this here. B bar is equals to minus 4i cap plus 5j cap minus 3k cap. And the G bar is equals to minus I cap plus 2j cap plus k cap. Since G is the centroid of triangle ABC, by the centroid formula, G bar is equals to A bar plus B bar plus C bar upon 3. Therefore, 3G bar is equals to A bar plus B bar plus C bar. Substitute the value of G bar, which is the minus I cap plus 2j cap plus k cap. A bar is a 3i cap plus j cap plus 4k cap plus B bar minus 4i cap plus 5j cap minus 3k cap and plus C bar. That we want to find out. And here we have here. Okay. See this here. Now 3 into this bracket, and again we will simplify this also. That is a 3 into I cap minus 3i cap plus 6j cap. 2 into 3, 6. 3 into k, that is a 3k cap. And after simplification of, that is a 3i cap minus 4i cap. Then you will get minus I cap. Next is a j cap and the plus 5j. Okay. And then you will get 6j cap. 4k cap minus 3k cap. You will get k cap plus c. Therefore, C bar is equals to minus 3i cap plus 6j cap plus 3k cap minus in bracket minus I cap plus 6j cap plus k cap. And after simplification, then you will get what is there? Minus 3i cap plus 6j cap plus 3k cap minus, and this minus and minus, that will become plus. Plus I cap minus 6j cap minus k cap minus 3i cap plus I cap. Then you will get minus 2i cap. And the next is a 6j and minus 6j. That will become 0j. And the last is a 3k minus 2k. You will get 2k. 3k minus k, sorry. 3k cap minus k cap. And then you will get 2k cap. And hence the coordinate of the third vertex C is a minus 2, 0 and 2. Now the next is in triangle OAB, E is the midpoint of OB. Here E is the midpoint of OB. Okay. And D is the point on AB such that AD as to DB is a 2 as to 1. D is a point on AB such that AD as to DB is a 2 as to 1. Next, if OD and the AE, this is the OD and the AE intersect at P, they intersect at the point P, then determine the ratio OP as to PD, OP as to PD using the vector method. Let A, B, D, E, P have position vectors A bar, B bar, D bar, E bar, P bar with respect to O. We have AD as to DB is a 2 as to 1. AD as to DB is a 2 as to 1. D divides AB internally in the ratio 2 as to 1. Therefore, by using the section formula for the internal division, 2 into B bar plus 1 into A bar. Therefore, D bar is equals to 2B bar plus A bar upon 2 plus 1. And after simplification, then you will get 3D bar is equals to 2B bar plus A bar. This is the first one. Since E is the midpoint of OB, therefore E bar is equals to OE bar is equals to 1 upon 2 OB bar. But what is the OB bar? OB bar is nothing but the B bar upon 2. Therefore, E bar is equals to B bar upon 2. Therefore, B bar is equals to 2E bar. This is the second one. What we have the first expression, that is the 3D bar is equals to 2B bar plus A bar. 3D bar is equals to 2B bar plus A bar. And here we replace the value of B bar, which is the 2E bar. That is the 2 in bracket 2E bar plus A bar. Therefore, 3D bar is equals to 4E bar plus A bar. Now see this expression. This is very important. 3D bar is equals to 4E bar plus A bar. Now divide this equality by first of all 5. We can write it like this. That is the 3D bar plus 2 into 0 bar. That is the O bar. I will write it. I will consider it as O bar upon 2 plus 3. And 4E bar plus A bar upon 4 plus 1. The LHS, see this here, LHS. The LHS tells us that LHS is the position vector of the point P which divides, this is the OD, which divides OD internally in the ratio 3:2. Where P is the point which divides OD internally in the ratio 3:2. RHS is the position vector of the point P which divides AE internally in the ratio 4:1. P is the point. That is, the P divides AE in the ratio, this is 4:1. Okay. But OD and the AE intersect at P. And therefore, P divides OD internally in the ratio 3:2. And hence, OP as to PD. OP as to PD, that is equals to 3:2. Now, the next problem. Now the problem number 11. If the centroid of the tetrahedron OABC is 1, 2, -1, where A is a 8, 2, 3, B is a 1, B, 2, C is a 2, 1, C respectively. Find the distance of P, A, B, C from the origin. Let G, whose coordinates are 1, 2, -1, be the center of the tetrahedron OABC. Let A bar, B bar, C bar, G bar be the position vectors of A, B, C, G respectively with respect to O. Then A bar is equals to, that is a I cap plus 2j cap plus 3k cap. B bar is equals to I cap plus bj cap plus 2k cap. C bar is equals to 2I cap plus j cap plus ck cap. And the G bar is equals to I cap plus 2j minus k cap. By the formula of the centroid of the tetrahedron, that is a O bar plus A bar plus B bar plus C bar upon 4. And after simplification, therefore you will get 4G bar. The position vectors of the O bar is a 0, 0. Therefore their sum is a bar plus B bar plus C bar. Now 4G bar, G bar. What is the position vector of the G bar? The position of the G bar is a I cap plus 2j cap minus k cap. And the A bar, next is A bar is a AI cap plus 2j cap plus 3k cap. B bar is here is a B bar, I cap plus bj cap plus 2k cap. Plus C bar, 2I cap plus j cap plus ck cap. Collect the terms of I, j, k, open the bracket, and then you will get here 4 into I cap, therefore 4I cap. 4 into 2j cap, 8j cap. 4 into minus k cap means minus 4k cap, and collect the terms of I cap. Here is I cap, 1 I cap and 2 I cap. That is the AI cap plus I cap plus I cap. Next is the j, 2j cap plus bj cap plus j cap. And the last is a 3k cap plus 2k cap plus ck cap. Take the common as I cap, j cap and the k cap. Here you will get A plus 1 plus 2 bracket complete I cap, 2 plus B plus 1 j cap. Next is a 3 plus 2 plus C k cap. Now equate the terms. That is A plus 1 plus 2 means what? A plus 3 I cap. And that equals to 4 I cap. Means what? A plus 3 is equals to 4. What about the j cap? that is a 2 plus b plus 1 means what? B plus 3j cap is equals to 8j means what? B plus 3 is equals to 8, and therefore you will get the value of b is a 5. What about the next is a 3 plus 2 plus c, that is a c plus 5, and that's equals to minus 4k cap. Therefore c plus 5 is equals to minus 4, and that's why c is equals to minus 9, and therefore the coordinate of the point P are A, B, C, which is the 1, 5, minus 9. The distance of P from the origin, it means that the squares of 1 square plus 5 square plus in bracket minus 9 square. 1 square is a 1, 5 square is a 25, and the minus 9 bracket square is a 81. And if you add it, then you will get the distance of P from the origin is a root of 107 unit. Now the next problem. Find the centroid of the tetrahedron with the vertices K 5 minus 70, L 1 5 3, M 4 minus 6 3, N 6 minus 4 2. Solution. Let P, P bar, L bar, M bar, N bar be the position vectors of the points K, L, M, N respectively with respect to origin O. Then what about the P? P bar is equals to 5i cap minus 7j cap plus 0k cap. L bar is equals to I cap plus 5j cap plus 3k cap. M bar is equals to 4i cap minus 6j cap plus 3k cap. N bar is equals to 6i cap minus 4j cap plus 2k cap. Let G bar be the centroid of the tetrahedron, and then by the formula, that is by the centroid formula, this G bar is equals to P bar plus L bar plus M bar plus N bar upon 4, and that's why 1 upon 4 in bracket P bar, that is a 5i cap minus 7j cap plus 0k cap bracket complete plus L bar, that is a I cap plus 5j cap plus 3k cap plus, next is a 4i cap minus 6j cap plus 3k cap plus, and the last is a 6i cap minus 4j cap plus 2k cap bracket complete, and open the bracket, then in bracket you will get 1 by 4 5i cap plus I cap plus 4i cap plus 6i cap. Okay, if we collect it and then their sum, okay, that is a 5i cap plus I cap plus 6i cap plus, then you will get here is a 16i cap. What about the j? Minus 7j plus 5j minus 6j, and here their total, that will become, here is a minus 12j, minus 4j is also, if their total is a minus 12j cap. And what about the k? 3k plus 3k plus 2k, and that is the 8k cap. And hence G bar is equals to, if you divide by the 4, and then you will get G bar is equals to 4i cap minus 3j cap plus 2k cap, and hence the centroid of the tetrahedron is a 4 minus 3 2. And in this way we have completed the exercise 5.2. Now we'll see in the next video. Till then, goodbye.